Hello, today I am going to solve my homework 2. I will create a new clean page. First, I will copy my question to solve better. We will transform NFA to DNF. Let's copy our question. Okay. I will name this state with A, B, and the final state will C. Okay, let's look at the initial state. If we have a lambda operation, we have to start with that, but we don't. So that we can start with A. Okay, state A. Okay, I won't draw this symbol. I will just use the transactions with the normal. Okay, first in the A state, if we go with the 0, we can go A and C. So that we will write that A and C. Okay. Then, we have a new state, by the way. In A state, if we go with the, if you notice, I don't use this symbol, just write quickly because we have limited time. If you write 1 with A, we will go B state, right? Then we have a new state. Okay, let's continue with B. In B state, if we go with 0, we will go C, right? So write the C state. And if we go with 1, we will go to the same state. It's B. Okay. Then write another state. It's C. In C, by the way, we should write all transactions. I don't know what was the name. Transition. I don't know, maybe transition. Maybe not transaction. Sorry. Let's write 0. In 0, we will go C. Just returning itself. And in C, if we go with the 1, okay, in C, 1, there is no 1. Okay, so that it will be empty. Then we write A state, B state, C state, and we didn't write A and C. This is a new state, okay? So we should write, I will clean this before drawing, and write A and C state with 0. Look at A. A with 0 going A and C. So just write A and C, okay? Just write. And for E, A, B, yes, A with 0 going A and C. And C, look at for C. C with the 0 is going itself A and C. So that A and C will be just A and C, returning to itself. We just taking the common parentheses, right? So that I will go one by one. In A and C state with 1, look at that. And A, we have 1, it's going B. In C, we don't have 1, so that just write B state, okay? We write all states, so we can draw our diagram. I will go with the pink, okay, yes. What was the initial state? It was A, right? So that I will write A state. Yes, A state. With A, going to the, go with 0, going to AC. Just draw. With 0 is going to AC, right? Yes, sorry about shape. We did this, so draw. With 1, go to B. Let's draw B. B. With 1, right? Then draw. With B, going with the 0 is going to C. Let's draw 0, going to C, right? Draw circle, yes, 12. B, 0, C, and 1 is going to itself, so that, like that, yes. In C, 0 going to itself, 0 going to itself, and 1 going to empty, trap state. 1 going to empty state, and there is some special feature in here. We should write 0 and 1 here. Okay, we did this. In AC state, with 0 going to itself, 0 going to itself, and 1 going to B. Yes, that's it. Thank you. Sorry, I didn't finish the question. In the last step, with diagram C, when you do the all transitions, you should decide the final state. And look at the NFA state diagram. As you see, there is one sorry, C, it's double circle. That means this is the acceptance state. So that in the DFA diagram, when you see the the final state, you should draw double circle. So that I will draw double circle here. Okay, sorry about shape. And here, and there are two acceptances in the DFA diagram. Okay. That was a nice question. Thank you for your time. I will go with the second question after stopping the video. Okay, let's continue with the second question. It was a very good question. If we go with the step by step, we have a final state machine. The language accept by NFA. We want to draw complement of this language first, convert it to DFA. After that, after we convert to DFA, we change the accepted states to normal states. Normal states will go to the accepted states. Okay, and change states. Yes. As we did before, we should write each steps so that I will name the states. And in state A, yes, with the curly bracket, thinner, yes, A state. If we go with 0, we will go to the base B state, right? In A state, if let's write it smaller, sorry. In A state, go with 0, going to B state. Okay. In B state, in A state, if we go with the 1, it will be empty, right? There is no 1 here. In B state, if we go with 0 and 1, so that I will draw a longer arrow, it will have 0 and 1. There's no difference. It will go to the C state. And C state, if we go 0 or 1, it will go to the empty. Okay, so that let's draw. What was the initial state? It was A. Okay, so that let's draw it. I will copy this picture. Yes, and create a new page for this. Okay. sorry, my bad. Let's come here and take a screenshot. Yes. Sorry, my bad again. I'm terribly sorry. I just want to make it better. Let's write it up, okay? Sorry. Yes, in A state, let's draw A. In A, with 0 will go B. With 0 will go B. And 1 going to empty. And B, 0 and 1 going to C. 0 and 1 going to C, right? And C was accepted state, okay? And C, 0 and 1 going to empty string. So that if you want to reverse, the complement, you should get rid of accepted state and add the normal states with double circle, okay? Add another circle too. So that we have changed the, yes, we accept we draw the complement of the language, okay? Thank you. Hello again. Let's continue. The third question. Prove that if L1 is regular and L2 regular, then so L1 minus L2, the set of all strings in L1 but not in L2. Okay. Given L1 and L2 are regular languages, L1 and L2 are regular languages. Since L2 is regular, its complements, the set of all strings not in L2 is also regular. L2 complement is regular. Sorry. This is because regular languages are closed under complementation. Now consider that language L1. What was instruction? Okay, we have shown in the lesson. L1 instruction L2 complement is regular because both is regular. Both L1 and L2 are regular. Therefore, L1 minus L2 equal L1 interaction between L2 complement is regular. Okay. We have shown L1 minus L2 is regular by using closer properties of regular languages under complementation and instruction. Thus, if L1 and L2 are regular, L1 minus L2 are regular. Okay. Okay. The last question. If, let's read it. Prove if L regular, prefix is L is regular. Prefix L is set of all strings which are proper prefix of string in L. If L is regular language, it means there are DFA that accept it to make a new DFA that accept all prefixes of strings L. We can start with the DFA and change it a bit. We look at DFA and mark every state that can lead to an accept state as an accept state too. By doing this, we make the new DFA accept all prefixes of the strings in L. Not just by complete strings, since we can build a new DFA, and new DFAs only recognize regular languages. We know that the language of all prefixes called prefix L. L also regular. Regular. Yes. That's it. Thank you for your time.